All right, after investigating the graphs and the equations of Q of x, F of x, G of x, H of x, and P of x on those previous pages, by answering the questions about each one of them, what are some general conclusions that you can make about when a function will be continuous at a certain x value, and when will there be point or jump discontinuities at a certain x values? So let's take a look about continuity at x equals a. So first, I want you to think about a very informal way of defining continuity. If you can trace a graph, so this is like so informal, right? So if I have something like this, and I can trace it without lifting up my finger or without lifting up my pen, then it is continuous. However, if I have something where I can trace it, but then I have to lift up my pen or lift up my finger, then we have discontinuity. And then there's two types. There's a point discontinuity, and then there's a jump. Okay, so that's more of an informal kind of big picture idea. So if you are continuous, we already know what that looks like. There's no break in the graph, but algebraically speaking, two things occur. Both pieces must approach the same y value, let's just say that y value is b, whatever that is. And then the second thing, when you plug in a, right, because they're talking about when x is a, when you plug in that value of x, then it has to equal that same y value. So this has to happen. When you plug in that x, you get the same y value that you got in part 1. If you have jump discontinuity, both pieces, let me just show you here, it might be faster if I don't have to write everything down. Okay, both pieces must approach different y values if you're having a jump, okay? And then the f of a may or may not be defined. That means one could be a closed circle, one could be open, but it doesn't matter. At jump discontinuity, the key point is that both pieces approach different y values. If you have a point discontinuity, this is important. They both pieces have to approach the same y value b. But when you go and look at what's defined, when you plug in the x value, it's not the same y value. So point discontinuity versus continuity, this is going to be a closed dot. This would be an open dot. Okay, so we make sure that we understand that component. All right, so let's take a look at this down here. For each of the functions below, we're going to determine the values at which the graph could be discontinuous. So we're going to determine the values where it could be discontinuous. Then determine if the function is actually discontinuous at those values. And then if the function is discontinuous, then classify the discontinuity as either jump or point. Show your work and explain your reasoning for each. Okay, so number 1, the first thing is no matter what, we had to have both pieces approach the same y value or both pieces approach different y values. When we're talking about pieces, we're talking about from the left and to the right of a certain number. So we are focusing on when x is -1. So we need to look and see as x approaches -1 from the left, g of x, and we're going to plug it in here. We're going to go negative, instead of x, we're replacing it with -1. -1 plus 4 squared plus 3. That's going to give me 3 squared is 9. -9 plus 3 gives me -6. So I'm focusing on that -6 in just a moment. Now I need to go to the right side. As x approaches -1 from the right, g of x, I'm going to plug in this absolute value. And instead of x, I'm plugging in -1 minus 3 minus 10. -1 minus 3 is -4, which gives me a +4 minus 10. And I get -6. So what does that tell you? It tells me that on the left and the right, I'm approaching the same y value. So I definitely do not have jump. I have either continuity because both pieces approach the same y value, or I could have point discontinuity because we're approaching the same y value. I have to do step 2. I have to see if that same x value gives me that same y value or not. So now I need to figure out where I am supposed to plug in -1. Well, none of these equal -1. So it says here, get this for you, give me 1 second. So since both pieces approach the same y value of -6, but g of -1 doesn't equal -6 because I don't have anywhere where I could plug it into. It doesn't allow me to plug in -1 into either function. So I know that -1 doesn't equal -6. Then g of x has a point discontinuity at x equals -1. Now let's take a look at number 2. Where on our constraint are we concerned? We are concerned this one ends right before -1 and this one picks up at -1. So we are evaluating what's happening at -1. So if I were to go as x approaches -1 from the left, g of x, and I'm going to plug in -1 into this function. -2, then I've got -1 plus 3 plus 2. This gives me 2. Absolute value of 2 is 2 times -2 is -4 plus 2 is -2. Okay. Now I've got as x approaches -1 from the right, g of x, and I'm going to plug it in on this one, -1 plus 3 minus 4, so that's going to give me 2. +2 minus 4 is -2. So the cool thing is they match. So that means I'm either going to be continuous or have point discontinuity. So now what I need to do, I need to figure out, this was step 1. Well, step 2 is going to evaluate g of -1. So -1 exists right here. So I'm going to plug in -1 plus 3 minus 4 gives me 2 minus 4, which equals to -2. Since both pieces approach the same y value of -2 and g of -1 equals -2, then g of x is continuous at x equals -1. Now let's look at 3. So we've got to look and see where our issues are at. In this case, we've got a couple of different issues. I can see that there's one is ending at 3 and one's beginning at 3. This one ends at 5 and this one begins at 5. So we've got to consider both. All right. So let's take a look. As x approaches 3 from the left, I'm on this function. I'm replacing the x with 3, and I get 3. Now I need to approach 3 from the right, which means I'm going to be on this second function. So I've got 3 squared minus 2 times 3, and I still get 3, right? So since both pieces approach the same y value of 3, remember I need to also figure out h of 3. H of 3 is equal to 3 because of this. Then h of x is continuous at x equals 3. Now let's take a look at 5. 5 from the left. I'm going to be using this function right here because I'm on the left side of x equals 5, and I get a y value of 15. This is going to be on the right side of the number 5, and so I plug it in to this function and I get 4. Notice the y values are different, which is going to be jump discontinuity. Since both pieces approach different y values, h of x has jump discontinuity at x equals 5. All right, let's take a look at this right here. For what values of a and b? This is a different type of question. We're trying to figure out a and b. Will the function below have a point discontinuity at x equals -3 and x equals 2? So we've got -3 and we've got 2. Well, we want point discontinuity. Point discontinuity says that the y values have to match. So we need to figure out the left side of -3, which is this equation. So 2x plus 3 needs to equal the y value. So we're going to have, when we plug in -3, so a and then -3 plus 3b, and I'm going to replace x with -3. So this function and this function have to equal each other when x is -3. That's what it's saying. So if I were to take a look at this, I would get -6 plus 3 equals -3a plus 3b. All right, so let's just take a look and simplify that. I get -3 is equal to -3a plus 3b. I'm going to save this for just a moment because if I have 2 unknowns, I need 2 equations. So let's take a look. In order for this to be point discontinuity at 2, I have got ax plus 3b needs to equal the 1/2 x squared plus 3x minus 1 when x is equal to 2. So I'm going to have a times 2 plus 3b, 1/2 2 squared plus 3 times 2 minus 1. So let's clean that up a little bit. I get 2a plus 3b is equal to, this is 4, half of 4 is 2, plus 6 is 8, minus 1 is 7. So then I have this equation. So let's review from previous math courses that we now have a system. So we've got -3a plus 3b, 2a plus 3b, this equals -3, and this equals 7. The easiest way is elimination. So I am going to multiply maybe this function by -1. This is going to give me -3a plus 3b equals -3. This one gives me now -2a minus 3b equals -7. Adding the b's cancel out, I get -5a is equal to -10. A is 2. Once I figure out A, I can take it back to any one of these. So I've got negative 3 times A plus 3B equals negative 3. I'm plugging it into that first one. Instead of A, my A was 2, so I get negative 6 plus 3B equals negative 3. 3B is equal to, if I add 6 to both sides, I get 3. B is equal to 1. So now I figured out the values of A and B.